So good morning, my name is Marcelo Friso. I'm Director of Sales with Intelligent Power Management, and I'm here to speak with you about the power efficiency at the cell site environment. So that's it's a key focus market for us, the cell sites on the wireless environment for the carriers, for the communication service providers. It's an environment that is remote by nature, it's out in the field, it's unmanned, and a lot of guessing takes place today. So we're here to talk about efficiency, why efficiency matters, how you achieve such efficiency. So we could speak on a power level or an energy level, and more than that, really it's efficiency. As we call ourselves Intelligent Power Management, it's intelligence efficiency. So looking at the cell site environment, I guess the first question to ask ourselves is what kind of pattern of consumption we have at a cell site environment and what kind of elements contribute to that. So as the chart shows here, you can basically put a breakdown of how the consumption takes place at a cell site environment or any building for that matter. But let's think of the cell site as an individual isolated ecosystem. It's a brick and mortar type of infrastructure, and it's got equipment running inside. It's got equipment that powers the wireless network, the radio, the RAN equipment, all the DC equipment that goes into making that RAN equipment execute the function that it's supposed to and provide the wireless for voice, for data, connectivity. And then you have a separate aspect of that is the equipment that is there to make sure that the environment is properly cooled. So all the air conditioning, the lighting of that environment, the smoke detector, the dehumidifiers, and everything that plugs into an AC outlet. So once you understand what's running inside, you kind of can break down on what is revenue generating, so all the RAN equipment, and what's non-revenue generating, which is air conditioning and lights and smoke detector and so forth. And when you look at a breakdown of a typical cell site, this is more or less what you see. About a third of all energy consumption on that cell site is not utilized by the revenue generating. And the biggest offender, as we have seen in the field, on this 1/3 is the air conditioning. The equipment running there generates the equipment running on the revenue generating side generates a lot of heat, and to dissipate that heat and to keep that equipment running at optimum temperatures, you need to cool down the environment, and the HVAC, the AC systems they kick in, they run a number of cycles, and that ultimately consumes energy. So that kind of paints the picture of what's there in terms of consumption, and from there we can start looking at how we can achieve that efficiency. At the end of the day, you need all the data to come in, you need to make sense of that data and essentially instrument and act upon those things. But a couple of bullets that are important for us to work with. The most efficient site is the one that will have the lowest OPEX. And by nature of that bullet, all the efficiency will drive to a lower OPEX, which is spending less money to run this non-revenue generating stuff is where we can impact, is where we can affect. And then the third bullet here is consistent metrics is a key element for measuring and achieving intelligence efficiency or energy efficiency. Ultimately, think of the cell site as being a very diverse ecosystem. It can be a rectangular type of installation, it could be a 10 by 20, it could be a 20 by 40 feet type of installation. They vary a lot on the field in terms of size and in terms of equipment running inside. So the only way to compare apples to apples is by establishing consistent key metrics that will allow us to put them side by side. And to get there, one suggestion we have here is that we leverage what the IT world has been doing somewhat successfully, even though there are some discussions to certain, some of these key indicators are not accepted by everyone without any dispute, but there are some out there that are used very successfully on the data center environment. And one of them that we're going to focus here for this, for the sake of this example, is the power usage effectiveness, or simply PUE. The PUE is a simple formula where you have your total facility power, so everything that's consumed on a data center when you look at the IT world, and you divide that by the power consumed by the IT equipment. So the IT equipment being the servers, the routers, the switches, everything that really powers the network and moves the data back and forth. When you divide that, you have a number. That number, the better number will be the one that approaches the number 1. So the closer you get to 1, the more efficient your environment will be. So if you have a 1.2, a 1.3, you can easily say that a 1.2 environment will technically, for the most part, be more efficient than a 1.3 type of environment. And that way you can get a Google data center that is 1 million square foot compared to a Facebook data center that is twice as big, and you can basically establish that comparison, and it's kind of a benchmarking exercise that happens in the industry, and like I said, you can do an apples to apples type of comparison. Another indicator that also comes from the IT environment, both by the way, the PUE and the DCIE, which stands for Data Center Infrastructure Efficiency, they're both suggested by the Green Grid organization. They have been widely adopted by the industry, and one divides the total facility power by the IT equipment, the other one does the opposite. And in this case, we have the IT consumption divided by the total facility consumption, and you find a percentage. And you basically have a sample table here showing how you can rate then from an efficiency perspective from the most inefficient environment to the most efficient environment. And that allows intelligent decisions. If you create a list with your top 10 most efficient sites, and you have your bottom 10 least efficient sites, you can make decisions and eventually replace equipment that is deemed not as efficient. You can properly cool that environment and make sure that things are taking, from an economics perspective, they are being taken into consideration. And then we basically get to how we achieve that efficiency. Key aspect of that is the data acquisition. You need to be able to collect the data, and data becomes information. It's a lot of data that's out there in the field. Once you instrument the environment and you bring that in, that instrumentation is going to be through a number of sensors, a network of sensors, and you bring that information in, and then you take the next step where you're going to be monitoring that environment and controlling. So in the example back to the cell site environment here, if you have HVACs running there and they're running in an uncontrolled type of fashion, in all likelihood they're running much more than they should. That translates into a wear and tear of the equipment, so it relates to the maintenance of that. You can put a dollar amount to that. If it runs more, it consumes more. If it consumes more, again, you can put a dollar amount to that. Kilowatts, they're easily calculated and translated into dollars. So essentially, by acquiring the data and monitoring and controlling that environment, you become able to achieve that efficiency. And that's what we are promoting here with the Intelligent Power Management solution. Our IPM solution is multi-vendor, it's completely agnostic from a vendor perspective, from a technology perspective. Anything, virtually anything that has current passing through can be monitored, and in most cases it can also be controlled. And by doing that, by monitoring and controlling, we can achieve the operational efficiency, which helps in terms of maintenance tasks. You can validate that work that should be done is being done. The work that your vendors and contractors tell you that they have done, you confirm, so there is an element of vendor compliance, and you can move from a reactive type of maintenance to a more proactive type of maintenance. Think of this as almost everybody drives a car, and if you have to do oil change, you can do an oil change that is based in time, every 3 months, every 5 months. It's not very efficient, but you can do that. Or you can do based on number of miles that you drove. It's a little better than doing every 3 or 5 months. Every 5,000 miles, you go and do that. But wouldn't it be much better if you do that only when it's time to do it? Because the oil, the viscosity of that oil has changed to a point where it requires to be changed. So that's basically the idea here. You move from that very reactive number of miles or number of months, you move into one that is event driven. It's performance driven. There is a clear trigger and it's not based on assumptions. And essentially by achieving that operational efficiency, as a byproduct, you have energy efficiency. And like I said, you can put a dollar sign into this as well. If you, instead of having to pay an insurance policy for your vendors and contractors, you pay based in performance, based in events, you can drive savings. And energy efficiency, like I said, kilowatts, you can easily translate into dollars. So if you reduce consumption, again, we go back to that pie at the beginning of the presentation, if you have 1/3 of all your spending to be in things that don't generate revenue, you ought to take care of that. And every time that you reduce by a certain amount of percentage points there, you're going to translate into fewer kilowatts consumed, and that translates in fewer dollars that go out of the window as well. And we are not only able to basically work with the things that are in the marketplace today, but we are very future-proof. We're ready to integrate with renewables and new technology that will come down the road. So when you think of augmenting the grid with solar, with wind, with energy storage systems, with new types of technologies of batteries that are coming down the road, the IPM solution is the ideal candidate to make that integration. So that agnosticity it's key to basically move in terms of putting a future into your investment. And particularly on the wireless side, when you talk about the North American market and FCC regulations, we basically have all the templates in place for all the NORS and DERS type of reporting, allowing the operator to basically remain within the deadlines allowed by the FCC to publish when emergencies strike. And here is a visual of what the IPM solution looks like. So from a monitoring and control perspective, the core of the solution is the Smart Hub. The Smart Hub, it's a very small unit, a 1 RU type of hub that goes into the edge of the network. So every environment that you're going to be monitoring, in this example a cell site, will have a Smart Hub, and that Smart Hub is going to be connected to a number of sensors. How many sensors, what that kit of sensor looks like, it will depend on what you want to monitor. But you can go to the environment and monitor your HVAC, make sure that filters are not clogged, that economizer, the free air cool solution is functioning in accordance with the outdoor temperature, for instance. An issue that happens in many markets, it happens here in North America, it happens outside as well, is ground monitoring. Those ground bars, copper bars that get stolen, we can basically monitor that and notify real time and reduce that liability for the network, for the personnel working on that as well. And then we can monitor the sources of energy as well, whether it's the grid power or some backup power through generators, through fuel cells, and like I said, energy storage solutions that will come down the road and in the future. And ultimately, what we do with that information, nowadays everybody talks about big data. So bringing that into the cloud and running the analytics is here where all the intelligence, the dashboards, the decision making will be taking place. Is, like I said, the collection, the data comes in, the data acquisition takes place, and then we do make sense of that and basically transform that into actionable information. So I hope you enjoyed this presentation and I appreciate the opportunity.